here is our example here. Ibrahim thinks that a particular spinner is biased. To test his theory, he spins it 100 times. The results are shown on the table. So these are the results. Here is my beautiful spinner, and these are the results. So he spins it 100 times, and you see your frequency here should be 100 times, and he gets a 1 only 13 times. He gets a 2 15 times. So he spins 1, 2, 3, up to 100, and these are the results. He gets a 3 16 times. He gets a 4 42 times. He gets a 5 14 times. And the questions now that asked are, calculate the relative frequency for each number of spinner. What is the relative frequency? What is the relative frequency? Remember, the relative frequency, we're talking about experimental probability. The relative frequency, how many times did he get it, each and every number, divided by the number of times the experiment was carried. All right? So here, what will be the relative frequency here? So he got only 13 out of the total, which is 100. So that will be 0. Or I can write it as 13 over 100, 13 over 100, 0.13. And here, 15 over 100, 0.15. And then here, 16 over 100, 0.16. Then 42 over 100, 0.42, and 14 over 100, 0.14. So here, this is the relative frequency. Now, this is what is getting. This is what the relative frequency would be. This is the experimental probability. This is the probability that he got when he carried out the experiment. All right, let's look at the second question. The second question says, compare the relative frequency with the theoretical probability. Remember, what is the theoretical probability of getting a 1 here, or a 2, or a 3, or a 4, or a 5? So you would agree with me, it should be 1 over what? 1 over 5. Yeah? But when you look at these, 1 over 5, 1 over 5 is 0.2. But here we're getting 0.13, 0.15, 0.16, 0.42, 0.14. And if we have to compare, you would agree with me that here, I would say the spinner is biased towards landing on number 4. So I can write that down. The spinner is biased towards landing on number 4. So this is what I'm just seeing from here, right? It's biased. Why? Because these are almost close to each other, although they are far from 0.2, not that far, but this is way far, okay? So let's look at question C, number C. How could the experiment be improved? So the experiment can be improved by carrying out many experiments. You can improve by carrying out the experiment many times. Then if you carry out, the more numbers you take, the more times you carry out the experiment, the more you get closer to what? To the theoretical probability. I don't know if you get what I'm trying to say. The more you carry out, you throw a dice, the more you are going to get closer to what? To the theoretical probability. So, and here you may have to work out the expected number of times an event might happen. And I'm going to give you this formula here. The expected number is the number of times, like here we say it 100 times, and in some other cases they will say do it 200 times, whatever. So the number of times multiplied by the probability. The probability is what was the experimental probability that you got. Okay? Let's go to the second question. The second question says, a biased coin is tossed 150 times. It lands on heads 51 times. It lands on heads 51 times. And estimate the probability that the coin lands on a head on the next throw. Okay, so that will be probability that it's going to land on head. It's 51 out of 150. So that will be 51 over 150. So that's the probability, okay? And then estimate the number of heads you expect when you toss the coin 650 times. And this is what we are going to use. So we are going to say the expected number. We are going to use the formula. Expected number, expected number will be equal to the number of times. What is the number of times? 650. 650 multiplied by the probability, which is 51 over 150. And whatever number that you get there, that will be your expected number of times. So that means if you throw in 650 times, the expected number of times that you should get ahead will be this number. Okay? Cool. And already I have work on Google Classroom, and I'll post it in a bit. Bye.